This is a T-nut. They are used in jigs, fixtures and furniture to provide a mounting point where parts can be easily attached or removed. The T-nut accepts a bolt that can be inserted or removed many times without damaging the wood, plywood or MDF. I'm going to show you a couple of approaches that I used to model this T-nut. First thing I did was use my digital calipers to determine the measurements of the T-nut. We have a base diameter which represents the diameter of this base. Material thickness represents the thickness of the material used, and it really looks like that it's just been injected, molded or something like that, so the material thickness is pretty much the same the whole way through. The overall height is the height from the bottom of the base to the top of the thread pocket. The thread pocket height is purely this thread pocket height here without the base. The diameter of the thread pocket is the outer diameter here, and the spike height and width is the height of the spike here and the width there. So let's go and start modeling this now. So I'm going to jump into the part design workbench, and I'm going to create a new body and then a sketch in the XY plane to model the base. So we're just going to put a circle in, relatively simple, then set the diameter of the circle to be the figure in the spreadsheet, which is the base diameter, which automatically fully constrains the sketch because it's a very simple sketch. Then we're going to pad it out to be the material thickness. Now the first time I did this, I went on and modeled the thread pocket first, which didn't quite work out the way I thought it was going to once I started adding the spike pockets and so on. So I'm going to model the spike pockets and the spikes before I model the thread pocket. So we're going to create another sketch, and we're just going to model one thread pocket, one spike pocket, and then what we'll do is we'll do a polar rotation of it to create the other three. So we are going to bring in the outside of the base, and then using a polyline just model the interior part of the spike pocket, and then we use a arc with a center and two endpoints to model the outer part. Now at this point we've got 1 degree of freedom, which is essentially this here, so it's either the length or the width, and I've got both of those. I've got the width defined in the spreadsheet, so we'll use that, and that is dot spike width. And then we're just going to punch that through the whole of the base. And one thing I have learned from watching other videos is when you get a complex model, which this one's not going to be, but when you do get a complex model, it can get a little bit confusing with all the pads and the pockets and whatever. So I'm going to name them to make it easier for me to remember what's what. So with the spike pocket, I'm just going to call it the first spike pocket. And then from there, what we're going to do is we're going to create a polar pattern and and around the normal sketch, we're going to produce 4 of them. So it's going to put the pockets around the full 360 degrees. And then I'm just going to label that additional spike pockets. Now the first time I went to model the spike itself, I discovered that I was doing some strange things. And what I did was I first of all tried to create a sketch on that face, bring this edge in so that I could then draw my spike on top. What I found was, that worked this way. What I found at the time was that this reference line here was actually on the origin line, and where I'd placed the spike pocket in the first place wasn't. So it caused me a few dramas. So what I did the first time was kill that sketch, is I actually did it on this surface. So I created a sketch here, again brought in this reference line, and I created firstly a rectangle representing the bottom of the spike, which, like so, set the, actually no, it wasn't there, it was, we didn't put it right out to the edge. I then set the width to be spike width minus 0.1, just to drop it, make it a little bit smaller, and then set the thickness to be material thickness, and made sure that the base of it was in the right place. As you can see now, it's sort of touching on the side. I possibly could have imported this arc and linked it to that. I didn't at the time, something I thought about afterwards. I then decided I'm going to create another spike, and I'll use, another sketch, and I'll use loft to loft it. So I went, all right, let's import that guy again. A little box here. There to there. We just made it 0.1 millimeters so that I could just get a, almost a point at the top. And we made the thickness of it the material thickness. I then crap, I've forgotten what I did. I then that one, part design, reorientated the sketch. Yep, I detached it, I moved it, left it in the same orientation, and then moved it 5 mil. In this case, I can't use the spreadsheet, so I'm just going to put 5 mil in. Close that down. You can see now that there is a gap between the two. I then selected those two sketches and used the loft tool to loft it. Oh, and no, I didn't. What did I do? God, this took me a while to get right, because this is one thing that I'm not very confident with. I did actually manage to make it work. Actually, I think think I did that one, and then that one. We added that one, and yes, that's how I did it, right? And so that got me my spike. I don't use loft very often, which is why it caused me a few dramas there. So I renamed it to be spike, and then with the spike I then also did a polar around 360, added 4 of them, and then renamed them to be additional spikes. And then I added in the spike, the thread pocket. So we'll add a cylinder in on the XY plane. Its radius was 7 something, and its height was 5 something. Quickly jump back to the spreadsheet. It was, the height is 8.5 and 7.5 diameter. So we can change that. 7.5, height was 8.05. Refresh that. Oh, sorry. It's a diameter of 7.5, which means it's a 3.75 radius. Refresh. Okay. So, from the purposes that I have, which don't really need a thread, what I then decided to do was I would just simply put a simple hole down the middle of the thread pocket. So I created a sketch, added just a circle, set its radius to be spreadsheet dot thread pocket diameter on 2 minus the thickness of the material, which is way less than what I was expecting, because I used the diameter, not a radius, I think. So let's set that again. Radius. Spreadsheet dot thread pocket diameter on 2 minus spreadsheet material thickness. Okay. Close that, and then just simply did a pocket the whole way through. Thread pocket. So we rename them. In fact, we'll call it the bolt pocket because it's actually something. And we'll call it a bolt hole. Now from here you could just go around and do some filleting and whatever just to finish it all off. So 1/4 mil. Be interesting to see how that one goes. Haven't tried that one before. Yeah, just did the one. Okay, so you know, that's one way we could do it. The other option, the other way I tried it, and we'll just delete a whole bunch of these things. We'll leave the spike pockets in place because that didn't really change, was the way in which I did the spikes. Oops, get rid of that, get rid of that, and get rid of that. In fact, let's just do the whole lot again, so we don't confuse it any more than I already have. Alright, so we create a sketch on the XY, circle, constraint by diameter of that one, spreadsheet dot base diameter, pad that out to be the material thickness. Okay, create a sketch on there to do the pockets again. So bring that guy in. Use polyline. We'll use a polyline to represent the outside of the pocket. And then an arc with 2 points to finish it off. 2. Set the width, oops, not that one. The width again to be the spike width. Close. Okay, forgot to do the renaming. Okay, so we cut that out, make a pocket through all, done. First spike pocket. Then we are going to do the polar again. Maybe 4 of them. Additional spike pockets. So now we're going to model the spikes. And I'm going to do that by creating a datum plane that references this face. So do that. And then we're going to create a sketch on that plane. So we bring in the edge of that face so we can draw the spike. Back to being front view. We use a polyline to do that. Just going to make it the full width of the pocket. It's vertical. We make the length of the spike what we've defined in the spreadsheet, so that's the spike height. And I'm sort of using them interchangeably, but that's what I mean. And then we don't need to set the width because that's already done. Now turn the datum plane off, and then we're just going to pad that out to get the spike. And ooh, that's interesting. I'm getting different results now than I got when I did it before, because I only was creating one solid. We set that reversed, and then we get it. So I've got the spike in place. I'm going to rename this so that it's a spike, and then we're going to do the polar, all 4 of them again, on the vertical sketch axis. And we'll rename them to be additional spikes. Now we're going to go and model the thread pocket for the bolt. So we're going to add a cylinder to the XY plane. I'm not going to change the offset. Its radius is 3.75 and its height is 8.05. And we'll name that the thread pocket. Now we're going to put the thread down the middle of the thread pocket. To do that, I'm going to use the Fasteners workbench, which I downloaded before. You can do that by going to Tools, Add-on Manager, which will bring up a list of all the workbenches. Scroll down until you get to Fasteners and then install it. Now, the reason I'm using Fasteners is because it has a threaded rod object that we're going to use. So come across and use that. We're going to insert it. And all it does is it gives us a plain cylinder. So what I'm going to do is make a few changes just so that we can get a threaded cylinder. So we click on it on the threaded rod. We change the thread property to true and regenerate drawing, and it creates a thread. In this case, I'm not too worried about what the thread is because, to be honest, when I'm going to use this in my jigs, I'm not even going to bother about it. I'm just going to put it in place as a way of showing where they go in the jig, and it doesn't have to be 100% accurate. The length of the threaded rod is defined in the spreadsheet as being the overall height of the T-nut. And then what we're going to do is we are going to transform the threaded rod and bring it to the top of the thread pocket. So again, it doesn't have to be 100% accurate, but we're going to do that. And then we're going to switch back to the part design workbench. So now that we've got the threaded rod in place, what I'm going to do is simply select it and then subtract it from the rest of the model. The cut, click OK, and voila, we have a thread down the middle. For my purposes, this model is overkill. I don't really need the threads in the pocket for the bolts, but I went through this to get a better understanding of FreeCAD, and some of these things I'm still very much trying to understand in my own head because for what I need they're probably overkill. But I hope you found something of interest and learned something from this. If you did, please consider subscribing to my channel and clicking the notification bell. That way you'll keep up to date with my videos. Thanks for watching.